And we're back. There were two problems I was not able to get to on the previous video, so we're going to finish those up today. Once again, this is the Unit 1 practice test. All right, the first video, we have a 25 Newton crate that has held the rest on a frictionless incline by a force that is parallel to the incline. And it's 25 newtons, that is the force of gravity. We could find the mass of the crate, but why bother? Because we know we're going to have to end up dealing with force, right? The incline is 25 degrees, that's theta, above the horizontal. Find the magnitude of the normal force. I'll just circle normal. Okay, so we have Fg equals 25 newtons, theta equals 25 degrees, and we want to find the normal force, question mark. So first step, draw a diagram. I'm sorry, I know everyone likes the inclines to go the other way, which makes perfect sense. I just don't know why I have that habit of drawing the inclines that way. So we'll call this theta. We have a crate with the weight pointing down towards the center of the earth, as always. We have a force applied pushing up on the block, keeping the block on the incline and keeping it from moving. We have the normal force, which is normal to or perpendicular to. Remember, normal and perpendicular are like the same words. Well, they mean the same thing in mathematics. So the normal force is perpendicular to the incline. And those are all the forces we have. So I can now draw a free body diagram to make a little more sense of what's going on. So we have the schematic, the sketch, which just basically puts into a picture what we read from the prompt. Now I'm going to take all these forces and draw them in a free body diagram so I can kind of get an idea of how all this stuff's going to add together. The most important thing when doing a block on an inclined plane is you have to remember to tilt your axes. It doesn't matter how your axes are oriented in general. You can orient them however you want to because they're just reference points. It's completely arbitrary. But I'm going to just tell you that when you're dealing with an inclined plane, you have to have the x-axis along the plane. It's just the problem would be way too difficult if you didn't tilt the axes like this. Okay, so drawing my forces, I have gravity, and remember all your forces in the free body diagram emanate from the center of the object. And normal force. And you notice right away that these two forces are along the axes we've drawn. So that's fine. We can deal with those. But this force I'm going to have to break down into components to force it to be along the axes. You notice there's going to be a point here, FGY, and there's going to be a component here, FGX. And these two components add together to give this resultant vector, which represents the weight. So I'm going to draw another free body diagram in which I just have the parallel and perpendicular components that are along the axis lines.